Pakita ko sa inyo yung syllabus natin na ginagamit, existing. Ang course outcome nyo, para ano kayo, we are directed on where should be heading. Alam nyo kung ano yung tinuturo. Saka alam nyo rin kung, okay, baka kasi mamaya, itong tinuturo or itong tinitingnan namin, labas na sa kailangan namin matutunan. So, course outcome natin for the prelims, one of our course outcomes, ito is just to differentiate the structure or the construction and operating principles of a water tube boiler from a fire tube boiler. So under that, meron tayong learning objective na ano lang naman, working principles lang. We'll start with the working principles, then we'll go to the structure of each boiler, ano pinagkaiba nila. Afterwards, ano yung mga nakakabit, mga boiler mountings, para saan siya. Then, we'll see if we can go to the general construction lang naman. Pero kasi, as long as we are inside the water tube and the fire tube boilers, hindi natin kailangan lumihis masyado. There will just be variations of each. So, yan. So, wait. So, meron ako dito ipa-flash. Ito yung sa simulator natin. Yan. Yung simulator natin na gagamitin yung Kongsberg. If you're familiar with it, ginagamit rin siya sa licensure examinations. And well, of course, sa lessons natin. So, dito tayo si-center. Ngayon, yung nakaset sa system natin ng Kongsberg ay full ahead. So, gumagana na yung boiler. So, ito mamaya, yung sa diagram ng mountings. Yung mountings kasi iba itsura niyan. Sa diagram, may symbol siya na kasama. So, okay. Gawin ko lang muna tong buong i-full screen muna natin. So, ito, habang kayo ay nagra-relax pagkatapos yung kumain, ipi-play ko lang yung video. Okay? This is a fire tube boiler. Should you have any questions, just raise your hand para ma-post ko yung video. Okay? Sige, ipi-play ko na.
Boiler, also known as a smoke tube boiler. And normally in our videos, what I do, I run through things like components, parts, how they work, and things like that. But in this video, I thought we'll take a different approach.
Wait lang, tag dito. Subukan kong i-mute ko yung microphone ko. Then, please let me know in the chat if you are hearing the audio. Okay?
Hi, John here. In this video, we're going to be looking at the fire tube boiler, also known as a smoke tube boiler.
Sir, wala po, sir.
Okay, sige. Kailangan pala naka-on ng mic. Okay, sige. Tutuloy ko na. Salamat.
And normally in our videos, what I do, I run through things like components, parts, how they work, and things like that. But in this video, I thought we'll take a different approach. Why don't we build a fire tube boiler together, and that way we can understand why it's built the way it is and how it works. In order to do this, we need to be a little bit creative, and that's why we invented the configurator tool. Now I absolutely love this tool, and I'm going to show you what it does right now. So here's our fire tube boiler. I'm accessing the fire tube boiler directly through a web browser, and if you check the video description area, you'll be able to access this 3D model through your web browser as well. You just click on the link provided. So what is the configurator, and why is it so good? Well, let me show you. Here's our configurator. As you can see, there are some names here on the right hand side, and there's an eyeball, and if we cross out the eyeball, we'll be able to hide and show different parts of the boiler. Let me show you how that works. Let's take a cross section first. So we can see here, you can see inside the boiler. And we've also got some arrows, and the arrows are going to allow us to see the direction that the exhaust gas is passing through the boiler. If we go back to our full view, we can remove parts like cover, for example. If we go down, we can remove the shell, and then we can have a look at some of the parts inside the boiler. Then we'll go down a little bit further, we can remove some of these tubes, they're kind of in the way. We'll get rid of some more tubes, and we can actually see what's going on inside the boiler. So the configurator is a pretty cool tool. In fact, it's probably one of the best things about Savory and the thing I like the most. So check out the link in the video description area, and you can do everything I'm doing direct through your web browser, and it's really going to help you to learn. But as I said before, what we're going to do is build a boiler. So let's just reset the configurator for a moment, and we've got a fire tube boiler here. Like I say, it's also known as a smoke tube boiler. We are going to do a video for a water tube boiler, but that's going to come a little bit later. So let's go up to the top. In fact, if we go back down, we can reverse everything, and we can see that we've actually just got an empty space. So in my factory, I've got this empty space, and I want to build a boiler there. So the first thing I need to do is to add some supports. So I'll mark out the area where I want to build the boiler. So there it is, this red frame. Next thing I should do probably is to add a shell. We'd actually put the cover around the shell. The cover is sort of like insulation, and the cover would go around the shell. So let's just do that for a moment. I'll take it off in a second. We've got the cover around. It's normally a bit thicker than what we're seeing here. And the idea with cover is that we insulate all of the shell in order to trap the heat inside the boiler for as much of it as possible. We don't want to lose the heat because we're paying money for combustion, for fuel and things like that, which we're going to learn about in a moment. So we'll insulate the shell and consequently the boiler. So we've got our shell. We're going to fill this up with water. Because the idea with the boiler is that we can burn some fuel, and we can heat up some water, and we can turn that water to steam. So let's imagine for a moment we try and fill up the shell. Well, that's not going to work out too well for us at this present moment because the water's just going to run out of the shell. So let's start thinking about what else we can add here. We're going to need a burner. We're going to need something to create combustion. We're going to be burning things like fuel, oil, and gas. So let's add a burner. Okay, so the burner's there. We've got a bit of a problem now because if we were feeding fuel into the burner and we're also feeding in air in order that we can have combustion, remember you need heat, fuel, and air, or heat, fuel, and oxygen in order to get combustion. That is a fire triangle. So feed all of that in, then we've actually just got it going into our shell, and that's full of water. Well, not really, this is leaking quite a lot, but this isn't really going to work out very well for us. So let's add some more parts here for a moment. We'll add a corrugated furnace. And we've still got a bit of a gap here. So let's just see what else we can add here. Maybe go down. That's something called smoke box. We've kind of filled the gap up a little bit now. We've added two ends onto our cylinder. There you go. We've got another end here. This is actually the smoke box on the end here. We'll discuss that in a moment. If we go down here, okay, so we've sealed off the furnace. So we're going to have fuel going to the burner. We've got our air being drawn into the burner, and we're lifting up the fuel, and we can then have combustion in the furnace, which is going to be this area here. This is actually a corrugated furnace. Let's take away the shell for a moment. So you can see quite a unique shape, long and cylindrical, and this is known as the corrugated furnace. Let's actually just go inside for a moment and have a look. Here we are inside, got our burner down the end. We're going to have combustion in this space here.
Okay, pag sinabi mong corrugated, ito yung ibig sabihin niyan, yung makikita niyo parang may mga waves, yung mga alon-alon. Ayan. Ito yung tinatawag yung corrugated. Parang katulad sa yero. Nakita na ka ng yero, di ba? Yung sa bubong.
Sir.
Ito ang tawag na corrugated. Ito, malaki lang yung corrugations niya. Pero kunyari, pag pinaliit mo, corrugations din yung tawag doon. Okay? Ayan, sige. Balik natin.
Now, go out We've actually just came out of the boiler. But we get to the end of the corrugated furnace. And then we've got the same problem as before. We're just sort of ending somewhere in our shell, and we're surrounded by water again. Okay, so that's not very good. Let's add a reversal chamber. You can see we've sealed off that area now. The exhaust gases are going into the reversal chamber. And then what's happening? Well, if we zoom out, and have a look around the side. It's actually sealed on this side as well. There are no holes or anything. The only place where there are holes are on this side here. So we've got the holes, and they're coming out of the reversal chamber. But now what? Well, that's still not very good. We're still just going to end up with a lot of water splashing around because remember our shell, which seals the whole thing in, should be full of water. Let's get rid of that shell again. So now what we need to do, we need to get the exhaust gas from here, from the reversal chamber, and we need to get it out through the smoke box. Actually see the connection here. That's going to connect to a chimney. And in order to get that exhaust gas to the smoke box in the end, we're going to have to send it from the reversing chamber all the way over to the opposite side. So let's do that. We're going to need to add some tubes here. This is why we call it a smoke tube boiler or fire tube boiler, because we're literally sending smoke through tubes in the boiler. The water tube boiler, as the name implies, has tubes that are full of water, and the smoke tube boiler has tubes that are full of smoke or exhaust gas. So let's add our tubes. Okay, so the exhaust gas is coming out of the reversing chamber, coming along here, from right to left, and then once again, we're going to hit loads of water. Right. So let's solve this issue. We need a front tube sheet. So there's our front tube sheet. And now we've got the exhaust gas coming out of these holes here, and also in the section here. And we need to turn that exhaust gas around and send it back through these holes here on the outside. Now normally, if we add some inspection doors, we can seal off this section here, and we can seal off smoke box, which is this section here. We can't really see much when we add the inspection doors, inspection hatches, so let's just remove those again. So the exhaust gas is coming out of these tubes here. And then we're going to try and turn the exhaust gas and send it back through tubes here. Unfortunately, at the moment, we don't have any tubes. So let's add those tubes in right now. Third smoke tubes. Okay, so we've got the...
Okay, so ang nangyayari sa kanya, binubuo niya ng unti-unti yung structure mo ng fire tube boiler. So, the principle of your fire tube boiler, kasi tinawag na fire tube, kasi nasa loob ng tubes yung exhaust, not necessarily fire, pero yung fire mo kasi yung after niyang masunog, the heat will remain through the exhaust. Yun yung niya, yun yung ginagawa dito. So, para masulit yung init, pinapadaan nila ng ilang beses. So, you have the first smoke tube, meron kang pangalawang smoke tube, and you'll have the third. So that, yung usok mo, tumatawid na niya, yung init, na itatransfer niya ng maigi sa tubig mo. Okay? Sige, tutuloy ko na para mapanood nyo.
Exhaust gas on the left, traveling now to the right, way to the smoke box here, and then we've got another problem. These tubes are not really sealing with the smoke box very well at the moment. So let's go down here. And what I was actually looking for was a back tube sheet. Normally I refer to this as the rear tube sheet, but here it's a back tube sheet. And as you can see, we've sealed off those tubes now, and the exhaust gas is going to flow out of these tubes, third pass tubes. It's going to come into the smoke box, and then, if we angle this correctly, we should be able to see where the exhaust gas sits, and it's going to go through the exit at the top here, spin around, and go to the chimney and to a stack. So we've got rid of the exhaust gas, and as you may have noticed, it passed 3 times through the water that would be within the boiler. So this is a 3-pass boiler. Let's look at the first pass. We go from the burner along the furnace to the reversal chamber, and that is one pass. Then add our second smoke tubes. The exhaust gas comes along here, and that is our second pass. We'll then add our third smoke tubes, and we have our third pass, which goes left to right. And then the exhaust gas has transferred a lot of that heat to the water, which is going to turn some of the water to steam. And the steam is going to collect at the top of the shell. The entire shell is not full of water. The water level would actually be somewhere around here. We want to submerge all of the tubes in water, and we want to make sure they're totally immersed in water, and that at no point does the water level reduce to a point where the tubes are not covered in water. If the boiler is in service, there's hot gas flowing through these tubes. The tubes have to be submerged or immersed in water. Otherwise you risk fracturing tubes, breaking the tubes, and you may have a boiler failure. Let's add the shell again, because I just want to show you how the boiler looks when it has a bit more of a simple construction. So we can add the shell. Let's just take off a few bits and bobs for a moment. We know about the burner, we know we need a source of combustion. Let's take off the ends. You can see we've actually got quite a simple design now. It's just a long cylinder, more or less. So we've got a cylinder. We fill up the cylinder with water. We've sealed the exhaust gas system, so it's not going to mix with water. And once we fire up the boiler, allow the exhaust gas to pass through the furnace and the tubes, etc., then we'll transfer the heat to the water, and we will turn it to steam. But as you can see, the boiler design is relatively simple when we break it down into its major components. But let's just reset everything for a moment, take a cross section so we can see some of the arrows. We can actually just go inside our boiler a little bit here. We can see that the furnace, corrugated furnace is here. The red arrows are going left to right. The red arrows will then reach the reversal chamber, which if we angle this correctly, we can see. There's the reversal chamber here.
Ayan, so nakikita nyo, di ba? Nagkakaroon ng multiple passes ng exhaust gas. So, yung ininit mo from the corrugated chamber, tatawid siya sa smoke chamber mo. Babalik ulit dito. So, makikita nyo yung direction ng arrows nyo. Nakikita nyo ba? Malinaw ba sa, Malinaw ba sa video? Okay, sige. So, yan. So that, ang mangyayari, yung, yung tubig mo, mapapainit. Hindi lang, hindi lang maliit na portion ng steam, ng boiler water drum ang mapapainit mo. Mapapainit mo yung buong boiler water drum. So yan, sige, tutuloy ko na.
We'll spin the exhaust gas around, send it back the other way, and then when it gets to the other reversal chamber at the opposite end, we'll spin it around once again. We come around this way, we can actually see that occurring. You can see the exhaust gas comes out of these inner second pass tubes. So those ones here. We'll spin it around, send it into third pass tubes on the outer periphery of the boiler, or closer to the shell. And then, as we can see, it comes left to right. So left to right for the corrugated furnace, right to left for the reversal chamber to the other reversal chamber, and then left to right again, all the way to the smoke box. And if we go along here, we should be able to see that. See the tubes connecting here. They're going through the rear tube sheet into the smoke box, and then the exhaust gas will exit to the chimney. So that's essentially how a fire tube boiler works. I hope you enjoyed this video. I hope you enjoyed having a look at our new fire tube boiler. I hope you enjoyed the configurator tool. I think that's one of the best things we've got on Savary at the moment. And I really do encourage you to go and check out the link in the video description area. Click on that link. You can do exactly what I'm doing now on your smartphone, on your PC, on your laptop, on your Apple Mac.
Okay, so do you have any questions dun sa construction ng ating fire tube boiler? May pahapyaw na siya sa operating principles, pero we can dive into it more later. So, do you have any questions? Okay, good question. Sige, sabi ni Nokos, bakit sir kailangan ng third pass? Okay, sige, hindi natin. So, ito i-drawing natin ang okay sa chamber niya. So, kaya ka may third pass. So, drawing natin. Ayan. So ito yung ano mo, 'di ba? Ito yung burner kunwari. Ayan siya. So kunwari ganyan na lang. Ganyan na lang. Kaya kunyari ganyan. Sabihin na ito yung corrugated section mo. Kunyari ganyan. So initially, itong makikita mong area dito, yan. May tubig yan. Tubig siya, yan. Kasi ito, meron kang dito ka nagbubuga ng apoy. Yan. Yan. So, syempre, saan pupunta yung init mo? Yung init mo, dito yan. Diyan. So, yan yung initial area ng ano. Yan yung initial area ng tubes sa ano mo, sa tubes mo. Okay, ayan. So diyan siya. Yung second so ang mangyayari ito. So ang initial direction niya papunta dito. 'Di ba? Yan, diyan papunta yung apoy mo. Ngayon, magkakaroon ka ng second pass, eto, dyan siya. So, ito, palitan natin yan. So, ngayon, magkakaroon ka ng mga tubes, ito. Kunyari yung ganyan. Ayan yung second pass mo. So, may mga tubes ka dito. Nara yan. Hindi lang masyado straight. Nara, dalawang tubes lang. So, yung second pass, dito dadaan yan sa loob ng tubes. Dito yan. Sa labas dito. Yung paligid ng tubes mo, may tubig ulit yan. May tubig yan. Yan, may tubig yan. Sir, hindi ba to ano? Hindi ba siya mako-contaminate dito? Meron yang ano, may harang naman yan. Kaya nga naman may smoke box kay, may harang yan. So kung babalik natin yung sa ano niya. Yan lang. Ayan, dyan pumupunta. Ayan. Di lang kasi kita lagi eh. Ayan, may... Ito yung second pass mo. Yung third pass mo naman, siya yung sa outer dito. Ayan. Ganun din, another set of tubes. Kaya mo kailangan ng third pass para ito, yung tubig, yung init mo, saka yung tubig, makakapag-transfer sila. Mapapainit mo ng mas maigi. Kasi kung dito lang yan, kung dito lang siya, sayang kasi. Sayang yung init and sayang yung pinapakulo mong tubig. Kasi mangyayari, pag kulang ka ng tubes, wala kang tubes dito, mas marami kang volume para sa tubig. Kaso nga lang, it will take more to boil your water. Kasi wala kang ano eh, wala kang means para magpainit ng tubig eh. Kasi wala kang tubes. So, kaya kailangan mo ng third pass. So, ano natin dito. Makikita, di ba? To. May mga butas na yan. Ayan, may third pass yan. So, yung nasa... Ito, di ba nakikita? Ito yung corrugated. You have the second pass, you have the third pass. Pupunuin mo ng tubig yan. May tubig yan sa loob. So, mangyayari ito, yung first pass in this direction, second pass in the opposite, third pass in the same direction as the first. Para nangyayari, salubong yung init ng tubig, salubong yung exhaust gases mo, and yung tubig. Para mas madali niyang mapainit, mas madali niyang makapakulo. So, ito yung first pass mo dito, yan. Dito sa corrugated. So, yan, nakikita yung structure niya. Dito muna tatawid yung apoy, exhaust gases. Itong tubes mo dito, dun yan papunta. Yan. Second pass mo, ito na. Yan yung second pass. Yung second pass mo, dito siya manggagaling, papuntang third pass. Ayan, yung third pass mo, pagkalagay na dyan, dito na siya lalabas sa exhaust mo. Ito na yung pinakatambutso ng boiler mo. Gets? Gets na?
Right.
Okay na, malinaw na. Nasagot ba yung tanong mo, Nokos? Okay, sige. O, dahil 30 minutes na tayo, I'll be giving you a 10-minute break para makapag-unat-unat. I want you to be back by 12:40, okay? Hihinaan ko lang yung sounds. Medyo malakas siya. So, ganun din yung say ano rin, yung kanyang construction din. hindi naman nagkakaiba. So you also have the tube, second pass. Meron kang return chamber, then meron ka rin third pass. Yan. So yung diagonal stays mo, that is for stability. Kasi kakargaan mo ng tubig yan eh. So yan, meron kang drain so that you can empty the boiler. So ito, meron kang instrument tube. This is for your instrumentation, yung mga pangsukat ng ano.
Yan mga yan, mga yan.
Ayan, yung pangsukat yan ng ano. Kunyari sa boiler water level, yan. Minsan, nandyan din yung... So, yung mga, ito, nandito. Yung sukatan ng pressure, nandyan din. Itong lifting lug, ito yung para sa, kunwari, yung... Pagsakay nyo naman kasi ng barko, nandun na yung boiler. Pero kung sakaling makakita kayo ng ginagawa yung boiler, ito yan, dito kinakabit yung lifting ano mo, yung mga hindi pwedeng strap eh. Ano yan? Kadena. Kadena yan. Kaya kabit dyan. So that you can place the boiler in its position. Yung manhole, ito, binubuksan lang to kapag depressurize ang boiler. Dito nyo physically may inspect ang boiler kapag ini-empty na siya. Yan din, pwede rin kayo pumasok dyan, pero it's not advisable na pumasok basta-basta dyan sa manhole. So, meron tayong mga steam valve. Ito, dito lumalabas yung main steam mo. Dyan siya. Safety valve, dito kinakabit dyan. Diyan kinakabit yung safety valve para pag na-overpressure, dyan lalabas. So, may dalawang safety valve yan. Sir, pareho lang ba ng sukat yan? Hindi. Yung sukat ng isa mas mataas slightly. Mas mataas siya ng onte para pag, kunyari, hindi kinaya ng initial na safety valve, dito siya lalabas. Okay? Nasundan ba? Nasusundan? Sige, tutuloy ko na lang. Okay, so makikita nyo meron kang economizer dito sa dulo. Ito yung dalawang safety valve mo. Makikita nyo meron siyang handle. May handle yan dito sa kabila. That is for your manual testing. Para hindi nyo na kailangan hindi nyo na kailangan i-pressurize yung boiler nyo to dangerous levels. So ito yung sinasabi ko kanina, instrument tube. Yan yung mga gauges. Mga instrumentation dyan nakakabit. Dito sa gilid yung level gauge so that you know how much water the boiler has. So, ang sukat mo ng tubig dito mamaya, makita nyo, sir, ba't nandito sa may bandang gitna yung low level niya? Because that is the lowest that the boiler should be running. Hindi po pwedeng dito sa pinakababa. Kasi pag nangyari yan, it will be too hot. It will be too hot for the water to remain as a liquid or as steam. Ano mangyayari? Yung steam mo, dahil sa sobrang init, yung H2O molecules mo will separate into hydrogen and oxygen. And if there is anything that hydrogen and oxygen are in common, pareho silang flammable. Pareho silang sumisindi. So if you have two flammable gases inside a pressurized vessel, sasabog yan. Naintindihan ba? Naintindihan? So okay, sige, tutuloy ko na. Ayan na. So, meron tayo ditong pump. Ito yung ating feed pump. Ito yung feed valve natin. So, in this case, isa lang ang pinapakita muna. Isa lang. Pero in reality, dalawa yan. Okay? So, sige, kargahan muna natin ng tubig yung ating... So, yan. So, okay. No cause, nakita mo yung direction ng ano, di ba? So, kinarga natin yung boiler up to its normal level above the tubes. So, ito makikita mo yung direction ng apoy. Tapos, syempre, yung direction din ng tubig. So, mangyayari dyan, yung apoy mo, yung heat niya, papagalawin niya yung tubig dito sa direction. Dito, papunta dito. Then, your second pass will be going the opposite. So, ngayon, yung tubig din naman will be moving on the opposite side. Going to the opposite. Yung third pass mo will again return to the initial direction. So, nangyayari, nagsasalubong yung tubig sa kayong init, mas madaling natatransfer yung init niya. Okay? So, tuloy natin. Ayan. So, pag nakapagpakulo na siya ng tubig, mag-generate na siya ng steam. So, pag nakapag-generate na siya ng steam, sige, ulitin natin ha. So, ulitin ko siya. So, pag nakapagpakulo ng tubig, will generate steam. Yun yung isusupply mo ngayon sa consumers. If you have reached the steam pressure, pag naabot mo na yung steam pressure na yan, titigil siya. Okay? So, questions about the fire tube boiler? Malinaw naman? Malinaw siya? Sige, I'll proceed with the water tube boiler. Total, ito naman din, isa-send ko rin naman sa inyo to. Okay. So, okay. Nililinis ba? Yes, may periodic cleaning din yan. Though, hindi mo kasi talaga mapapasok yan doon sa loob. That's why you have chemicals and you usually treat the water itself. So, tawag natin dyan dosing. So, para hindi ka magkaroon ng scales, hindi magkaroon ng, when you say scales, yung tubes mo, ito, para hindi siya magkaroon ng layer. Kasi magkakaroon to ng pag hindi mo treated yung tubig ng maayos, nagkakaroon siya ng impurity. May impurities yan, naturally. May kalawang, may calcium compounds. So, kung nakakita ka na ng chalk, o kaya yung, sabihin natin parang semento, parang ganun yung chemical composition ng scales mo. So, mangyayari, mababalutan yung bakal. So, ngayon, yung bakal mo, pag nabalutan ng parang lupa yan, o nabalutan niya ng parang putik, makakapag-transfer ba siya ng heat efficiently? Magkakaroon ba ng heat transfer yan?
Hindi po, sir.
Okay, hindi siya magkakaroon ng magandang heat transfer. So, nasasayang yung init. So, imbis na napapainit niya kagad yung tubig, it will take a lot longer for you to boil the water. Eh di ibig sabihin nun, mas marami kang nakokonsumo na fuel. So, hindi siya matipid. So, kailangan bakal pa rin yung surface niyan. Walang impurities na kumakapit or walang scale na nagpo-form. Ngayon, pag nagkaroon din ng scale yan, you will have localized heating. And pag nagkaroon ka ng localized heating, pwede kang magkaroon ng rupture ng pipe dahil sobrang init. Kusa na lang, lalambot yung bakal. At dahil pressurized pa rin yan dahil sa init, pwedeng mabutas yung bakal mo. Okay? So, yung paglilinis niyan, yes, periodically nabubuksan siya, nalilinis siya to an extent, pero hindi siya nalilinis ng mababrush mo isa-isa. Ginagawa natin dyan, dinidrain natin yung tubig. Tinatanggalan natin siya ng heavy saka light impurities by draining the water. Ayan. So, I hope that answers your question. So, I'll proceed with the water tube boilers.
We're going to look at how water tube boilers work. Specifically, we're going to look at water tube boilers that are employed in coal-fired power stations. We'll look at all of the main systems associated with these large water tube boilers, and we'll look at the main components, and then I'll tell you exactly how the whole thing works. Now, before I get started with the video, I just want to say that Mo, our head 3D artist at Savary, spent a lot of time working on this model, and we agreed that we should open it up to the public for free, at least for the next 3 months, so people can actually use it and check it out. And so I've put a link in the video description area. Feel free to check out that link, where you can play around with the boiler and do everything that you see me doing in this video. So let's now take a look at our water tube boiler. Here's our water tube boiler that we modelled in 3D, and as you can see, there's quite a lot happening with this boiler. It would be quite difficult to explain using a diagram, or perhaps even using the 3D model as it is right now. So what we did, we changed the model slightly, and we used our configurator to break it down so that we could see inside the 3D model, and we could also isolate each of the systems, and I can explain to you exactly how those systems then work. So let's start with the fuel system. In order to show you the fuel system, I'm going to have to hide a few more bits and bobs, so just bear with me a moment. So I think we've hidden enough parts. Let's zoom in and have a look at our day silos. Now we're feeding coal into the boiler, but before we feed it directly into the boiler, we have to store it briefly, and then we're going to send it to one of our pulverizers. So we've got one silo, 2, 3, 4, and these 4-day silos usually give us enough capacity for between 4 to 8 hours, sometimes 12 hours, and that means if we get a problem with a conveyor in the coal yard or something like that, we can keep our boiler in service because we can feed the coal directly from the day silos rather than feeding it all the way back from.
Okay. So dito ang water tube natin is sa planta. Hindi siya necessarily sa barko. Sa barko mas ginagamit natin ang fire tube boilers as opposed sa water tube. And later may explain yan kung bakit. Okay? Sige. So tuloy lang natin muna yung video.
From our coal yard. The day silos feed down into our coal pulverizers. You can see them coming down here. You can also see coming down here, quite narrow actually. And they're going to feed down the shaft here into our coal pulverizer. The same setup is present on all 4. See once again, if I come across here, comes down from the silo, across and down, and it will drop into the middle of our coal pulverizer and will pulverize the coal. When we pulverize coal, we're essentially reducing its size, drying it and classifying it. Classifying means that we're sort of passing it through kind of a filter, you could say, in a way, or a grate, and that ensures that the coal is the correct size when it gets to the boiler. We don't call it a filter or a grate, we call it a classifier, and usually it's a rotating object inside the coal pulverizer itself. If you want to learn more about coal pulverizers, then I will put the link in the video description area, because we've actually got a tutorial for that as well. Once we've ground and dried and classified our coal, we're going to send it out of these tubes here. See them coming out, and I'll follow them around. You see them coming across here, and they're all going to feed in. We'll just zoom out slightly. Going to come around here, and they're going to feed in to our burners. Now let me just configure the model for a moment. I'll hide some parts and we can go in and have a look at the burner and the wind box. So we're going inside the furnace now, and our coal is going to be sprayed into the furnace through here. Let me see if I can get a better angle with a bit more light. You can see there's a nozzle here. In fact, let's just go over the other side, perhaps the lighting is slightly better. There's a nozzle here. We're going to spray the pulverized coal out of that nozzle. We're going to light it. We're going to get combustion. And around the outside here, we're also going to blow air in as well, which is going to ensure that we get very efficient combustion. Behind these tubes, which I can now hide, is actually what they call a wind box. So we can see it's coming in like so. And our wind box here allows air to fill up this space, and the air is going to be then pushed into the furnace. We have two main air systems associated with the water tube boiler. That is primary air and secondary air. So let's zoom out and we can have a look at those systems, because we're pretty much finished with the coal side of things. You can see coal came into the day silo, it dropped down, came down here into the pulverizer, pulverized it, and then we sent it pneumatically along these tubes, along here, and into this entire area. See all the pipes going in, and then we're going to blow it along here and into the furnace, and we'll ignite it and we will get combustion. You can see it's happening on both sides of the furnace, 2 pulverizers per side. But let's have a look now at the primary and secondary air circuits.
So, ang pinapakita pa lang niya yung air intake saka yung sa combustion. So, medyo magiging komplikado to dahil malaki yung sistema nyo. Pero, iniisa-isa naman niya. Iniisa-isa niya kung paano nagde-deliver ng fuel, paano magde-deliver ng air for your combustion, saan nangyayari yung combustion, and how is the water boiled using this setup. Okay? If you have any questions, do raise your hand or mag-ano lang kayo sa chat. Ha?
Okay, so I've rigged the model up now to show us the pulverizers and also to show us the primary and secondary air systems. So let's follow them through for a moment. We've got our fans which sit down here. These are actually our primary fans. Let me just see if I can show the secondary fans as well. Okay, so now we've got all our fans shown. The primary and secondary air fans are usually of the centrifugal fan design, although the number of fans and the type of fans that you use really does depend on the boiler design. This item here is an air preheater. We're going to have exhaust gas coming through here, and same on the other side. And then we're going to use that exhaust gas to heat up the air, which passes on this side. And then the air is going to be heated up before it goes to the boiler. We do this because it improves the efficiency of the boiler. We don't want to blow cold air into the boiler and continuously cool the boiler down. So we'll recover some of the exhaust gas heat by allowing it to be passed to the air, specifically the secondary and primary air systems. Now the primary air system, just back out here, comes along here. This is our cold primary air system. Comes up. We can follow it over to here. It's actually going to come into this duct here, and then it's going to be fed downwards to our cold pulverizer. Goes in at the base, and then we will use that air, which will be blown up through the cold pulverizer, and then along the tubes and into the furnace.
Okay. So, ang ginagawa niya dito, di ba dinurog na niya yung solid fuel mo, which is your coal. Dinurog niya, pinadaan niya sa classifier. So, tinignan niya kung gaano kapino. Papadaanan niya ngayon ng mainit na hangin yan. So, yung coal mo, sabi natin yung coal dust mo na, dala na ng hangin, papasok na yan sa furnace. Ngayon, sa oil-fired boiler mo, you pass through the oil, then may atomizing air yan, tapos isa-spray niya ngayon yung oil to make it droplets para mas madaling sunugin. It's using the same principle here, but instead of liquid, you're using a solid. So for you to make it a droplet, hindi siya madadala lang ng hangin. So, ang ginagawa nyo, dinudurog nyo na siya kagad, initially, into smaller pieces so that the air can carry it. At pag inintroduce mo siya sa isang mas mataas na area ng heat, sisindi na ngayon yung coal mo. Or, kung meron man flame na sa loob, mas madali na niya masusunog yung pulverized sa coal. Understood? Masundan ba? Okay, sige. Tuloy na lang natin.
Go over slightly. You can have a look at this other connection, which is this pipe coming out of here, or this duct, I should say. And that duct comes across, and that is going to be our hot primary air connection, and that also feeds down into the pulverizer. So there's a cold and a hot primary air connection. Other than the primary air system, we have the secondary air system. The primary air system controls how much fuel we are burning. If we add more fuel, we add more primary air. The secondary air system, which if I spin around here, you can take a look at, is this one coming through here and here. Let's go over to the top side. We can actually follow the secondary air system, see it coming along here, and also on this side. And the secondary air system is going to go to our wind box. Now we can actually hide and show the wind box. See if I can get that up now. So it connects to our wind box. See it coming out here. and it will then be blown into the furnace through the wind box. You can actually see the main coal tube coming along here where we feed the coal in, and around the outside we can blow secondary air into the furnace, and the secondary air controls how efficiently we burn the fuel. So primary air controls how much fuel we burn, and secondary air controls how efficiently we burn that fuel. Now you might be wondering how we can control how efficiently we're burning that fuel. Well, we can sample the exhaust gas or the gases of combustion from the boiler, and when we do that, we can read the CO2 levels and the oxygen levels, and we can determine if we need to supply more air or more secondary air to the furnace or less. In this manner, we can ensure that combustion is occurring as efficiently as possible, and we actually call this whole control process combustion efficiency. So we've talked about the coal system, we've talked about the air system. Let's now take a look at the water and steam systems. I'm going to hide a few parts again so we can get a good look inside the boiler. Okay, so let's have a look at where our boiler feed water enters the boiler. Boiler feed water is going to come through this pipe here, and it's going to enter an area known as the economizer. Now this is just a serpentine type of heat exchanger, and the water, our boiler feed water, is going to come in, flow around here, going to go back and forth until it gets all the way to the top, and then it's going to come across, and it's going to go up to our steam drum. Now in order to make this a little bit easier to see, what I'm actually going to do, I'm going to reset the model, and now we can see boiler feed water comes in here, flows up, and comes across to our steam drum. Now once we get to the steam drum, our water that we've delivered from the economizer is still water. So there's no change of state, no change of phase yet to steam. Although that does occur in the steam drum, it's just at the moment the water is simply too cold. Actually what I should say is not that the water is too cold, it's simply that the boiling point is too high because the water pressure is very high. Remember that as we increase the pressure, the boiling point also increases, which means we need a higher temperature in order for the water to boil at a higher pressure. The water from our economizer is usually going to be at a pressure higher than 200 bar, which means more than 2,900 psi, and thus our boiling point is correspondingly high as well. So from our steam drum, we're then going to have to send the water down into the furnace, and we're going to use downcomers for this. So here are our downcomers. We've actually got 6 of them coming out of the steam drum. They're large pipes, and the water, which is relatively cold, has a higher density, which means it's heavier, and it's going to drop down through the downcomers, and then it's going to enter our mud drums. You can see we've got 2 large mud drums here, 1, 2. We call them mud drums. They're not actually full of mud, it's just that a lot of the sediment and other things that are flowing around inside the water system will tend to accumulate inside these 2 drums, and then occasionally we'll have to open the drums up and remove the contents inside the drums. So we call those mud drums, and the top drum is called...
Ayun, yung sinasabi niya na mud drums, nakokolekta yun sa ilalim. Sa fire tube mo, meron din yan. Pero, mas madali siya i-drain kasi mas maliit. So, yung putik na yan na naiipon, if that is not collected and if that is not removed from your water, yan yung kumakapi sa tubes. Yan yung nagpo-form ng scales at pwedeng sumira ng boiler tubes nyo. So, yan.
Steam drum. From our mud drum, we're going to send the water up, and see the pipes coming up here, the tubes, and we are now inside the furnace. You can see that we've got tubes on all sides. That is a side wall. That is also a side wall, and we also have a front and rear walls as well. Let me just zoom out for a moment. And if we zoom up, you can see we've just got a square-shaped box. that surrounds our entire furnace area. We'd have combustion at this level, and all of that heat is going to pass to the tubes, or a lot of it I should say, and we're going to transfer that heat to the tubes via radiation or convection. There are three ways you can transfer heat: radiation, conduction and convection. But within the furnace, which is where we are right now, in this area we transfer a lot of the heat radiantly, but radiant heat is only transferred by line of sight. So let's go up the boiler for a moment, travel to the top of the furnace, go all the way up here, all the way up, and we can see that we've got four headers, 1, 2, 3, and 4, and these headers then send steam to our steam drum. See them all connecting onto the back of the steam drum here. Now it's important to realise that as the water has travelled up through the furnace, the water has turned to steam. So it's entered at the bottom of the furnace here, travelled upwards, it's got very hot, and what we actually get out at the top is wet steam. Some people would say saturated steam, but technically saturated steam should be completely dry. It should contain no moisture molecules. At this stage in the process, as the water is flowing through the boiler, some water molecules still exist. Steam is a colourless and an odourless gas. So you can't see steam. The steam that we think that we see when we say, oh look, that's steam, is not actually steam. It's just water molecules floating in the steam. And we need to strip those water molecules out in order that we can get dry, saturated steam. And that's what we want to send to the turbine. If we don't send dry, saturated steam to the turbine, we end up damaging the turbine. So we've got our wet steam. It's got a very high dryness fraction, which means it contains very little moisture, but still a little bit, and it's going to come into our steam drum. In our steam drum, we're going to use baffle plates, scrubbers, and maybe steam cyclones to separate some of that moisture from the steam. The moisture or water drops that get separated can then be recirculated in the boiler, but the steam we get out of our steam drum should now be quite dry. It should be saturated dry steam. So let's just add our steam pipes out, and in order to do that we've got to figure out where we're going next. And where we're going to is our primary superheater. So now we've got our pipes coming out of the steam drum. We're going to send the steam along here, down this way. We're going to come across. In fact, what I can do, maybe I'll just hide a few systems here just to show you that in more detail. Hide the economizer. Steam comes out, comes across here, down this way, and into our primary superheater.
Okay, class. Since it's 13:15, I'll be giving you a 10-minute break para di naman kayo maburyo masyado. Okay? So, come back at 13:25.
Now we're adding more heat in our primary superheater in order to heat up that steam even more. The location of the primary superheater is important. Notice that our actual area of combustion is here. So those hot exhaust gases, which contain significant amounts of heat, are going to blow up here, and they're going to come around the top, and then, in fact, if I add the superstructure, perhaps that would be a better way to show it. They're going to come up around here, and then they're going to flow back down again, and come down here, and then go out. Switch back to our full screen mode for a moment. We'll hide the superstructure. So when the exhaust gases come around and then down again, they're cooling down as they come around this area and go downwards. So our primary superheater is not in one of the hottest areas of the boiler. We're just heating that steam up a little bit again before we send it back to a hotter region. So let's now add our secondary superheaters. And we can see that we've got a steam pipe coming from the header here. It's flowing along this way. It's coming from our primary superheater along here to our platen superheater. It's going to come down. Let me just hide the downcomers, get them out of the way as well. The steam is going to flow down here. It's going to come back up. And then we'll go to another header. We'll discharge the steam then to our finishing secondary superheater. Both of these superheaters, this one here and this one here, are secondary superheaters. The one on the right is a primary superheater. The difference with the secondary superheaters is that this one is referred to as a platen superheater because of the type of heat exchanger used, and this one is our finishing secondary superheater because it is the last superheater or the last heat exchanger that the steam passes through before it exits the boiler. The steam comes in here, flows down, up, down, up, and then it will exit through this header to our high pressure steam turbine. And that is how water flows through our water tube boiler and becomes steam. But we're not finished with our water tube boiler just yet. After the high pressure steam turbine, we'll often use, I say often, not always, a reheater. We'll take the steam from the high pressure steam turbine and feed it back into our water tube boiler where we can reheat it again before it goes to our intermediate pressure steam turbine and then our low pressure steam turbine. Not all water tube boilers have a reheating section, but our design does. So let me just show you that. This is our primary reheater, much like the primary superheater, which was in a slightly different location, it was slightly lower down. But the steam from the high pressure turbine is going to enter through here. It's going to travel along through our serpentine heat exchanger once again. We're going to go up here, and we've got quite a squiggly path, but eventually it's going to reach our superheater reheater and then out to the intermediate pressure turbine. And at this point, we've actually finished with the steam cycle in the water tube boiler. The only system that we could discuss now would be the exhaust gas system. And if I set up the configurator correctly, we can see that the area of combustion would be around here. Our exhaust gases are going to come up here, come across, down, and then they'll come across this way, and down here, through our air preheater, this section here, and then out to our exhaust gas cleaning system, which will usually involve some sort of flue gas desulfurization, an electrostatic precipitator, or a baghouse maybe, and then...
Ayan, kung titingnan nyo, di ba nandito yung combustion chamber? Ito, yung tubig nyo, ayan siya, yung blue. Bumapasok siya, pasikot-sikot yan kasi, ang water tube mo, nasa loob ng tube yung pinapakuluan. So, eto, meron akong compilation ng, belang. Ito pala. Ito siya. So, lipat natin dito. So, yung water tube boiler mo, it boils the water inside the tube. So, nasa labas ngayon yung exhaust. So, usually, ito pang mga maliliit lang to. Mamaliit. And ito, well, ito, sa planta, malaki siya. So, it's either sobrang liit o sobrang laki. Yung sa mga mobile, tulad ng mga barko, hindi siya advisable. Wala pa akong nasakyan na barko na water tube ang gamit. Wala pa. Though exhaust gas boiler, ito kasama to. So ito itatawag natin composite boiler. If you have a combination of an exhaust and a oil-fired boiler, composite ang tawag dun. So ibig sabihin, you are boiling, you are using your exhaust, yung usok mo galing sa tambutso, to also boil or to help boil the water. Mas matipid ang iyong fuel consumption. So ito yung difference nila. Dito nakalagay smoke tube, pero dapat fire tube yan. So you have here the smoke tube or fire tube mo, low pressure range, which is, yun lang naman ang kailangan natin sa barko. Ang pinakamataas mo lang ay nasa 7 bars. So mataas ang 7 bars na pressure sa boiler natin. Ngayon, kung gagamit ka ng water tube, kailangan ng ang pressure range mo ay significantly higher. So, kaya niyang mag-produce ng up to 100 bars. Eh, wala naman tayong paggagamitan sa extrang 90 bars or sa extrang 93 bars. So, kaya ginagamit lang natin oil-fired boiler na fire tube. Ngayon, ang kanyang disadvantage naman, you have a higher thermal stress sa fire tube kasi nga, you are exposing your heated tubes directly to water. So, yung temperature gradient masyadong malayo. Masyado siya malayo. Unlike sa water tube mo, mababa lang kasi konti lang yung tubig, so mas madaling pakuluan. So, the thermal stresses experienced by your tubes are significantly lower. Low quality and quantity of steam. So, mababa na nga yung pressure niya, hindi pa ganun kainit yan. Kasi sa fire tube, you still need a superheater to further dry your steam. Unlike sa water tube, mataas na kagad yung quality niya at mabilis siya magpakulo kasi konti lang yung tubig na pinapakulo niya pero tuloy-tuloy. Tuloy-tuloy yan. So, sa kanilang dalawa, your fire tube is less efficient. Mas marami kasing napoproduce yung water tube for a given amount of time at a higher pressure. Mas maliit din. Mas maliit din yung water tube boiler mo compared sa iyong fire tube. Ito yung sinasabi natin large diameter tube and small diameter tube. So ito, so that you can accommodate more exhaust gases, you need a larger diameter. Ngayon, yung tubig mo naman na kailangan mabilis mapakulo, kailangan mas maliit siya. So that it can be easily evaporated inside the tubes. Yung smoke tube naman, yung fire tube natin, mas malaki siya. So, mas malaki, mas mababa yung pressure, mas mababa rin yung quality and quantity of steam na napoproduce niya as opposed sa water tube. Mas magaan ang water tube, mas maliit, but it can carry or it can produce the same amount of the same steam pressure with a higher quality. Pinagkaiba nga lang nilang dalawa, ang isang advantage ng fire tube mo, there is a lesser risk of explosion. Hindi katulad sa water tube. Ngayon, kung fire tube mo ay low pressure, tapos ang water tube mo ay high pressure, so sino nga yung mas madaling sumabog? Sino yung mas prone sa explosions? So, do you have any questions? Meron kayong insights? Anyway, I will be also sending you all the links dito sa ating lesson. So, if there are no questions about the differences ng water tube, dito tayo sa boiler mountings. So, pag sinabi nyo mountings, ito yung mga fittings. Ito yung mga kinakabit sa boiler natin. So, hindi ko na ipi-play yung video niya dahil malabo yung pagkakasabi niya. Yan lang. I-flash na lang natin. So, ayan. Oops, balik natin. So, ito. Ayan. So, kung titingnan nyo dito, di ba, meron tayong safety valve sa dalawa. If you can see here in your, nakikita nyo ba yun sa simulator natin? Nakikita nyo siya?
Sir, right, sir. Kita po.
Okay. So, dalawang safety valves. So, pag pinoint ko dito yung mouse, meron kayo makikita sa lower left. Safety valve 1, safety valve 2. Ayan, nakikita nyo sa lower left. Ito yan. So, ganyan yung symbol niya. Yung may parang kidlat spring yan. You have 2 water level indicators, which is this. So, kung i-unfreeze ko siya, ayan. So, kung babawasan ko to, para ko muna tong pump natin. Babawasan ko siya, makikita nyo na, bumababa yung level. Nakita nyo bang gumagalaw? Nakikita nyo ba siyang gumagalaw? Ayan, bumaba na yung water level. Or ito, kahit sundan nyo na lang yung numero dito kanina, nasa, ano to. Ayan. Oh, tumigil siya sa tumigil siya sa pagtakbo. Balikan natin, boiler combustion. So, na-stuck siya sa 20. So, anyway yan, bababa yung water level nyo yan. So, nagloko yung simulator natin. Yan. Ayan. Oops. Ayan. So, nakita nyo, sobrang ano na. Sobrang baba na. Nagkaroon na tayo ng alarm. Bilang ano, hindi siya nag-respond kagad. So, yan, pag pwedeng kargahan natin ng tubig yan. So, meron kang low. Ito yung low mo. Then you have the high level here. So, may pressure gauge ka. Dito hindi kita yung pressure gauge eh. Ito, meron kang differential pressure dito. Sa gilid. Ito, yung DP. Ayan, so nag-normal na. So, yung pressure nyo, yan, makikita nyo dito. Yung numero na 5. Pero in reality, meron din kayo makikitang hiwalay na pressure gauge. Steam stop valve. Ito yun. Shut off valve. So, yan, nag-high level na siya. So, para ulit natin yan, buksan natin yung blow down valves mo. Meron kang, sa top blow down, meron kang bottom blow down. Yan. Yung feed check mo, ito yun. Ito. Feed check valve. So, pag sinabi mo check valve, non-return valve yan. Ito yung blow off cock. Ito mga blow off cock yan. Hindi lang kita dito yung manhole eh. Yan. Yan, para na natin yan. Para yung manhole hindi kita dito kasi schematic diagram to eh. Pero in reality meron yan. Yung doon sa natin. Meron yan manhole. So yan. Boiler mountings. Boiler accessories. Balik natin. Ito. Yung feed pump. Ito, this is your boiler water feed pump. Ayan. Ito makita nyo, di ba? May pangalan naman. Boiler water, feed water pump. Yung injector mo, dito makikita yan sa ito yung injector mo. Fuel injector yan. Ito yung nagsusunog so that you can have heat and pressure. Yung economizer, Ito, exhaust boiler yan. Ito siya. So, makita nyo, may dumadaan na tubig pa rin. So, ito yung exhaust mo galing from your main engine generator saka sa boiler mo. Dito rin dumadaan yan. Meron ding ano. Yung air preheater, ito gamit dito sa time na to, gamit natin ngayon is steam. So, mainit na yan. We can also use, on the other hand, atomizing air. Pag nagsa-start, pag wala ka pang steam. Yung superheater naman, dito siya, mapupunta siya, ito. Superheater vent, dito yan. So, that's outside of the boiler. Kung ang boiler nagpapakulo ng tubig, yung superheater mo nagtatanggal ng moisture sa steam. Yung steam trap mo naman, accessories yan, depende sa machinery. If they're using steam, kailangan ng steam trap so that it can catch the moisture that the steam carries. Pwede kasing magdala ng yung steam mo ng moisture, and that is what you call wet steam. Sisirain nun yung mga equipment mo like your, punta tayo sa ating turbo generator. Ayan. Sisirain niya to kasi gawa to sa, etong turbines niya very fine. Ang clearances yan maliliit. So pag siniksika ng tubig yan, your water will act like a solid. Kaya maingat kayo dapat if your equipment needs dry steam, you have to feed it dry steam. Wet steam kasi medyo delikado yan eh. Okay? So, do you have any questions? Anyway, I'll send you all the links para ma-review nyo. And I'll also send the recording later on. So, do you have any questions? Magsisend na rin ako ng tingnan natin sa ano. Actually, you can search in Google kung ano itsura ng isa-isa netong mga, kung anong isa-isang itsura niyan. You can search in Google and I'll give you the time. Diba? So that you can also prepare for your next course. Okay? So if there are no more questions, meron ba?
Wala naman po.
Wala naman. Okay. So, malinaw naman lahat sa inyo. Malinaw naman. Okay. So, if there are no more questions, I will be dismissing you early. Thank you for attending class and do prepare for your courses and I'll see you this week.